In this lesson, we'll be solving numerical questions on work energy and power. I had earlier made a video where I explained the concept of work energy and power. I derived some formulas there, and everything you need to know about work energy and power is there. So I want you to click the link in the description and watch the video, or you can click the card that just popped up at the right hand corner of your screen to watch it. Now, let's solve this question. A body of mass 50 kg runs up a set of steps of a total height 3.0 meters. Find the work done against gravity. From the question, we are given a mass of 50 kg, and then the height of the stairs is h is equal to 3.0 meters, and they are asked to find the work done against gravity. So also we are given that acceleration to gravity is equal to 9.8 meter per second square, and so we are asked to find the work done against gravity. Now let me illustrate this question. So this will represent the stairs. So this is the stairs, and then this is where this body is. So let's call this point A, and then point B, and then point C. So this body is 50 kg, and so we are given that the length from here, which is B to C, which is the height of that steps, is equal to 3.0 meters. And so asked to calculate the work done against gravity. Now, work done against gravity is equal to the gain in potential energy by this body. So remember, while this object is moving from this point A to point C, is working against gravity, alright, because it's covering a height. Now, the work done is equal to the formula for potential energy is given by mass times acceleration to gravity times height. So work done is equal to the mass of the body is 50 kg multiplied by the acceleration to gravity 9.8, then multiplied by the height, which is 3. So we have that work done against gravity is equal to 50 times 9.8 times 3. So if you punch it in your calculator, it's going to be equal to 1470 joules. So from this question, we have that option C is the correct answer. So let's move to the next question. So question number 2 states, find the potential energy of a body of mass 10 kg standing on a building floor 10 meters above the ground. Then the acceleration to gravity is equals to 9.8 meter per second square. So what we are given mass of the body as 10 kg. Then we are given the height of the floor as 10 meters, and then the acceleration to gravity is equals to 9.8 meters. Then we have to find the potential energy of the body. So let me illustrate this question. So a body of mass of 10 kg is standing on a building floor. So let this be the body of mass 10 kg, and then let this also be the building floor. So the height of this building floor from the ground, let's say A and B, is equals to 10 meters. And so I asked to find the potential energy of this body. So the formula for potential energy is equals to mass times acceleration to gravity times height. So this is equals to the mass of the body is given as 10 kg multiplied by acceleration to gravity 9.8 times height 10. So equals to 10 times 10 is 100, 100 times 9.8 is 980 joules. So the potential energy of the body is equal to 980 joules, which satisfied the option D of this question. So let's move to the next question. So question number 3, a body of mass 4 kg is acted upon by a constant force of 12 newtons for 2 seconds. Calculate the kinetic energy gained by the body. So solution, let's write out the parameters we have. We're given mass as 4 kg, then we're given the force acting on the body as 12 newtons, and then the time is 2 seconds. Then we're asked to find the gain in kinetic energy of the body. Now let me illustrate this question as usual. So this is the body 4 kg, and then a force of 12 newtons is being acted on it. Now the formula for kinetic energy is given by half times mass times velocity square. Now we have mass given in the question, but we don't have velocity. Now we can get velocity from one of the Newton's law of motion, which states that v is equals to u plus at. So this v is the final velocity, this u is the initial velocity, a is the acceleration, and then t is time. Now from here, we know initial velocity because initial velocity is equals to 0 because this object started from rest. The object was there before a force started acting on it, so it started from rest. And so we don't know acceleration, but we know time. So, but then to get this acceleration, we have a formula: force is equals to mass times acceleration. We know force and we know mass, so let's use this formula and find acceleration. So let's divide both sides by m. Divide both sides by m. This and this cancels. Then acceleration is equals to f over m. So the force given in the question is 12 newtons over the mass given in the question is 4 kg. So acceleration is equals to 4 into 4 is 1. 12 divided by 4 is 3. So acceleration is equals to 3 meters per second square. So this is the acceleration of this body. So we're going to plug in the value of a, which is 3, into this equation and then find our final velocity. So when we do that, we're going to have v is equals to 0, which is initial velocity of the body, 0, then plus acceleration of the body, which is 3, multiplied by the time, which is 2 from the question. So the final velocity of the body is equals to 2 times 3, which is 6 meters per second. Now that we have gotten the velocity of the body, let's plug in that velocity into this equation and then find the kinetic energy. So we have that kinetic energy of the body is equals to half times mass of the body is equals to 4, then multiplied by the velocity, which is equals to 6 square. So this is equals to half times 4 times 6 square is equals to 36. So 2 divided by 2 is 1, then 2 divided by 36 is 18. Alright, then 4 times 18 is equals to 72 joules. So this option A is our correct answer. So let's go to the next question. Now, if you are still watching this video by this time, please, I want you to support me by subscribing to my YouTube channel, like and share. It will help and motivate me to make more videos. So question number 4. A motor does 1500 joules of work in 10 seconds. Find the power of the motor. Now, the power of the motor is given by work done over time taken. Now, power is the time rate of doing work, and from the question, don't forget to write out the parameters first. So you have that the work done from the question is given by 1500 joules, and then the time is 10 seconds. Now we're asked to find the power. Alright, so work done from the question is 1500 joules divided by the time taken, which is 10 seconds. So this and this will cancel. We have that power is equals to 150 joules per second, which is equivalent to 150 watts. So this option C is our correct answer. Let's move to the next question. So please remember to subscribe to my YouTube channel, turn on the post notification bell so that each time I post a new video, you'll be the first to watch it. So question number 5. A body of mass 10 kg climbs up 10 steps, each of height 0.2 meters in 20 seconds. Calculate the power of the boy. Alright, so we are given that the mass of the boy is equals to 10 kg, and then it climbed up 10 steps each of height. Height is equals to 0.2 meters, and then the time is equals to 20 seconds. We have to calculate the power of the boy. Now, let me illustrate this question for easy understanding. We have a total of 10 steps. So this is 1, I have 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just doing this so that you understand it better. So this is a total of 10 steps as covered by the young boy, right? So then this, and so from the question we are given that the height of each step is 0.2 meters. So it means that from here to here is 0.2 meters. From here to here is 0.2 meters. From here to here is 0.2 meters, all the way to the 10th one, which is from here to here, 0.2 meters. So the height of this staircase is given by 0.2 multiplied by the number of steps, which is 10 steps. Now 0.2 times 10 is equals to 2 meters. So the height of these stairs is equals to 2 meters. Alright, so we asked to calculate the power of the boy. Now remember, power is equals to work done over time taken, and then work done is equals to mass times acceleration to gravity times height, then we have over time taken. Then the power of the boy is equals to the mass of the boy is given by 10 kg multiplied by acceleration to gravity, which we are given as 9.8, then times the height of the stairs is 2, then over the time covered by the boy, which is 20 seconds. So we have power is equals to 10 times 9.8 times 2 divided by 20. Just plug this in your calculator the way it is. So we have 10 times 9.8 times 2 divided by 20. This will give us 9.8. So this is 9.8 watts. So the power of this boy is this option A, which is equals to 9.8 watts. So let's move to the final question. So this is the final question. So it says a pump lifts 200 kg of water through a height of 10 meters in 20 seconds. Find the power that is done by this pump. So we are given mass of the water is equals to 200 kg, and then through a distance of this, so this is height of 10 meters, and then the time is 20 seconds. We are given acceleration to gravity as 9.8 meter per second square. They were asked to find the power of the pump. Now the power, as we all know, is given by work done over time taken. Then work done is mgh over time. So from here we have that m is equals to 200 times g is 9.8 times h, which is 10, then over time, which is 20. Now if you plug this in your calculator, you have that power is equals to, you have 200 multiplied by 9.8 multiplied by 10 divided by 20. So you are going to get that your power is equals to 980 watts, which is this option A. So thank you for watching. Please remember to subscribe to my YouTube channel, like my video, share it with your friends, and have a nice day.